This demo is basically for support of chrono library. This chrono library is a part of C++ 11 standard, 11 and onwards. So for supporting C++ 11, we have created one additional interface and providing that interface. So that interface is basically having three types of thing: time point, seconds in any format like millisecond, nanosecond, or second, and there are three type of interface: informative, inform every, and inform in. So in inform, let's go one by one. So when I'm opening this inform 80, I can show you some simple model. So this is the state machine. So in this, basically, we can see, yeah. So in initial stage, we have defined one time pointer object. So in that time pointer, we are taking the current time and we are adding the duration, and this time point object we are passing to the informative function. So now in time point, basically, as soon as that time get expire, then timeout happen, and in timeout we can see this timeout print is mentioned. So now I can run this model and show you how this is working. So now I'm building this one. Yeah, so this model is built. Now if I run this, then we can see timer valid print is coming. So now after 5 seconds, timeout happens and this pass result is print. So here in this model, basically we can change the time that I forgot to mention earlier. So if I go to this state machine, initial, so here different time we can put in the format of chrono library. So second, millisecond, nanosecond, anything we can put, and we can add to the time point object and pass the time point object in informative. Now coming to the second interface, now I'm cleaning this field, and so I have different test cases also. So only one test case I am explaining here, just for time constraint. So this is the another test case where I can show you the model. In this model, the state machine is same, but the interface which we use is inform every. So here we can pass this time in the form of second, millisecond, or nanosecond. So if suppose somebody want to pass time in the form of millisecond, he has to write ms. So this is the basically one feature present in C++ 17. Now suppose if I am passing 350 millisecond, so 3.5 millisecond, this timeout should happen. So second thing, suppose if I want to pass time in nanosecond, then I can mention here ns, then it will work. So as of now, let's see for millisecond. So I'm yeah, in timeout also same. In timeout, basically some prints are there to verify like timeout is happened and this test is passed. So now I'm going to build this model. Yes, this is built, and if I am running this one, so yeah, this timer value came, and this timeout, one times it got print, second time it got prints, and third time it is giving timer cancel, because we are having a counter of, we have having counter variable which is initialized to 3. So inform every means every time this timer will get expire and it will print the timeout. So that's why I have since given 3.5 second. So it is printing this value at every 3.5 second. Now coming to the third thing, it is inform in. So first I want to clear that build, basically inform every. Okay, and now coming to the inform in. So this I'm closing. So this is also having a same model. So I'm just opening this inform in state machine. So you can see this initial. Yeah. So here you can see in this example, I am just passing S for second. So 5 second is passed here. If suppose I want to pass in milliseconds, so I can put ms, as I already explained, and so directly we can pass this 5s or 5ms. This is the C+ chrono facility provided in C++ 17, and timeout is here. So this timeout. Now I'm building this model. So in this case, timeout will happen in 5 seconds. So now I'm running this. So timer is valid, print came, and after 5 seconds, that timeout happens. So yeah, so there are 3 interfaces which we have provided: inform in, inform AT, and inform every.